Now let's look at one that's a little bit more, done a little bit differently. So this is telling me that 3 times x, which I could have written just 3x with no dot, because 3x is understood to mean 3 times x. 3 times x is 15. Again, you can probably look at that and say x has to be 5. But suppose you didn't know that. In this case, if I add or subtract something, it's not going to get x by itself. I really want to say x equals something, not 3x's equals something or 2x's or anything. I want just x. What is x equal to? So I've kind of got to get rid of the 3. I think of this as saying that the 3 and the x are glued together. They create what we call one term. And we'll see in some of the other upcoming problems that we'll do the significance of that. But if we want to get x by itself and not have 3 in front of it, how could I do that? Well, this is the same thing as 3 over 1 times x. And I could have written that x over 1, but that won't help me get to my goal, so I'm not going to bother with it. Now, if I have 3 divided by 1 times x, and I want to get it to be x, what could I do? Well, I could multiply this by 1/3, because this will be 1/3 times 3 is 3 over 3, which is 1, meaning 1x, right? That's how we multiply. Multiply the numerators and multiply the denominators. So this is just x, 1x, which is the same thing as x. What happens on the other side? I took my equation, my original equation, and I multiplied by 1/3. So I've got to take the other side and multiply by 1/3. So this is, I'm going to write 15 as 15 over 1 times 1 over 3. All right? That's going to be equal to 15 times 1 is 15, and 1 times 3 is 3. This is 15/3. Now, what is 15 divided by 3? Check it out. It's 5 with no remainder. So 1x equals 5, or x equals 5. And again, you could kind of look at that problem and see that that was the case. So this is how we solve a problem where we have a number, a term, a number in front of x. Some number of x's equals some number. Whereas notice that here what we had was just 1x, but we had something added to it. When we have something added to it, we've got to get x by itself. Here, we add or subtract what we need to do to get the x by itself. And here, the way that we got x by itself was we had to multiply or divide something to get the x to be 1x instead of 3x's or however many x's the original problem might have represented. Okay, let's look at some other problems like that. Okay, 1/4 of x is 20. Now, this is starting to get into numbers big enough, what x equals, that you might not be able to figure it out that easily in your head. If I said 1/4 of x is, let's say, 2, you might say, oh, x would be 8. But this has a kind of a fairly big number equal to x. So we want to use our methods for getting x by itself on one side of the equation so that we can just solve for x even if we can't quite figure out what it's equal to by looking at the original problem. Okay, now, if I add or subtract anything, a number, I'm not going to get rid of x, right? Because I could have 1/4 x minus 2 or 1/4 x plus 3. Adding or subtracting is not going to get what I want, which is x equals something or other. But what about multiplying or dividing? Well, is there something I can multiply this by so that I just get x, what I call plain old x, 1x on this side? And the answer is yes. I can take my original problem and I can multiply by 4, also called 4 over 1. Because 4 is the same thing as 4 divided by 1. Anything divided by 1 is itself. So 4 is equal to 4 over 1. But if I took this side of my equation and multiplied it by 4, if I had two things that were equal and I multiplied 1 by 4, they're not equal anymore unless I multiply the other side by 4. So I've got to take this side and multiply by 4. And I'll call it 4 over 1 also. What the heck? All right, 4 times 1 is 4. 1 times 4 is 4. So this is 4/4 times x. And that equals 20, which I'm going to express as 20 over 1, times 4 over 1. 4 divided by 4 is 1, so this is 1x. 20 times 4 is 80. 1 times 1 is 1. So this is the same thing. 80 divided by 1 is just 80, right? 1x is just x, so this is x equals 80. Now, in the writing of this out, I had a few choices, and I could have done the presentation of my work a couple different ways. I'm going to go back now and do it another way to show you that I would have gotten the same answer. So my original problem was 1/4 times x equals 20. Suppose instead of saying I multiply by 4 over 1, I just said I multiply by 4. Okay? Suppose I did it this way. 20 times 4 is 80, right? 4 times 1/4 x. For this side, I probably, in order to make sure I'm multiplying correctly, I would want to say 4 is the same thing as 4 over 1 times 1 over 4. And instead of writing x, I could have said this is 1 over 4 times x over 1. I could have done that. 4 over 1 times 1 over 4 is 4 over 4, which is 1. So this is 1 times x over 1. 1 times anything is itself. So this is x over 1. And x over 1, it just means x divided by 1. So that's just x. So the answer here is x equals 80. So sometimes there's different ways you can write these things out. And any way that's correct is fine. Again, if you're taking a class in school, the teacher might prefer a certain approach. And as long as it's equivalent, there's a lot of ways to do problems. You know, there are often alternate ways to write things out or even to conceptualize things. As long as they're correct ways, you know, my expression is there's a lot of ways to skin a cat. There's different ways to do problems sometimes. So I'm just kind of giving you a couple options. And you may want to do what you're doing in class. You may want to pick what makes most sense to you that you prefer and do it that way consistently. That's fine.